Hey guys, today we're going to be discussing on naming ionic compounds, and we're mostly going to be focusing on multivalent metals in ionic compounds. So, when it comes to multivalent metals and ionic compounds, we have to understand that some elements can form multiple different stable ions. So, let's say, for example, iron. Iron can be found as iron 2 plus, and iron can also be found as iron 3 plus. Let me just use a periodic table to better describe what I have just said. So when we look at the periodic table uh, and relate back to multivalent metals in ionic compounds, we see that transition metals, which are in the center of the periodic table, they are normally the elements that have more than one oxidation number or charge. Um, we can take an example of titanium. Titanium, which is right here, we see that titanium, it has a charge of 4 plus and a charge of 3 plus. So we know definitely that titanium has one charge of 3 plus, and we know titanium has another charge of 4 plus. This is when we write it out. But now we have to focus on how will we know which distinct charge to use when writing it in a compound. What we have today is a very special and easy system that allows us to know what charge is on the ion. What we're doing is we actually put the oxidation number into the name. So let's take an example of iron 2 chloride. And remember, nothing is capitalized when writing out the name of the compound. So when we have iron 2 chloride, we also notice that we have brackets here and Roman numerals. What does this mean? We write the oxidation number, which is right here, as a Roman numeral, and we surround it with brackets. This is only for the metal, which is in this case iron. So let's take an example, and I'll explain it to you guys from there. So in this example, we will have copper 1 oxide. Right away we know that there are brackets and a Roman numeral of 1. Therefore, the oxidation number of copper, which is our metal, is 1. So here, copper has formed a copper plus 1 ion. Notice how I didn't write 1 here. It's because we already know that 1 positive copper already exists. So now how would we write these chemical formulas when we are given the compound in words like copper 1 oxide? So let's understand that the bracket system makes it very easy to find the formulas of transition metal compounds, since we are given the oxidation number for the metal ion. In this case, we are given the oxidation number for the metal ion, which is 1, and we only have to predict the charge on the nonmetal as usual using the periodic table. So let me write this out as steps. So step 1, we stated that we would have to find the oxidation number of the metal within the written compound. And then our second step, in order to write a chemical formula of a multivalent metal ionic compound, is that we have to predict the oxidation number of the nonmetal using the periodic table. And our last and third step, to write a chemical formula, we know that a crossover is involved. So let's take an example. Let's say if we had copper 2 chloride. Here we definitely know that copper has a 2 plus oxidation number. So it'll be written as Cu2 plus. We know that it has a 2 plus because of the number written in brackets as a Roman numeral right beside copper, which is 2. So, in this case, we have found the oxidation number of the metal within the written compound. Our next step would be to predict the oxidation number of the nonmetal using the periodic table. So in this case, we have chloride as our nonmetal. So when we go back to the periodic table, chloride is in group 17, and when we take a closer look at the periodic table, the charge on chlorine would be chlorine 1. Notice how I didn't write a 1 beside the negative, because we already know that a negative chlorine already exists. So now that we have completed the second step, let's now complete the crossover step. Now in this case, what we did, just like in the first lesson, was to cross over the charges of both elements to another element. So the 2 plus from copper went to the right side of chlorine, and the negative 1 from chlorine went to the right side of copper. So when we write this out, it would be Cu, which is copper, chlorine 2. We see this because of the crossover between the charges of both elements. Now, how about writing the multivalent compound if we are given the chemical formula? So let's focus now on writing the compound if given a chemical formula. When we name a multivalent ionic compound, we must first include the oxidation number on the metal ion in brackets. So make sure you have a oxidation number inside of brackets next to the metal. And then, because we cannot use the periodic table to predict the charge on the transition metal, we need a way to figure out this charge. And this is a formula, a technique that we call the reverse crossover. Reverse crossover is basically the reverse of what we have just done for the first part, for figuring out the chemical formula of a given compound. Now what we're going to do is take an example. Let's take an example of cobalt 2 and oxygen 3. Alright, so the two elements involved here are definitely cobalt and oxygen. However, we still need to find the oxidation number on the cobalt ion to put it in brackets. So now we're going to figure out how to identify the oxidation number of our metal, which is cobalt, and put it in brackets. So in this case, we would have to perform a step called the reverse crossover. And what we would do here is, instead of crossing from the top of each element, we would now cross from the bottom of each element to the top of the other element. So it'll look something like this. Now we are back to having cobalt 3 plus and oxygen 2 plus. This right here looks very familiar when we wrote out the written form of the chemical formula of cobalt 3 plus, oxygen 2 plus. So now what we have to do is this form right here, it gives you the charges on each ion now. Oxygen has an oxidation number of, it should be a 2 minus, and cobalt has an oxidation number of 3 plus. We must check that the nonmetal has a correct charge, and indeed, according to the periodic table, oxygen will have a -2 charge. So in this case, we have successfully identified the original charge of each element. So therefore, when we would have to write this out, this chemical formula would be written out as cobalt, no capitals, cobalt 3. This is because we see here cobalt has its original charge of 3 plus. Therefore, when we wrote out this chemical formula, we know that cobalt 3 plus was used. And therefore, it will be cobalt 3 oxide. Other than the brackets, all other naming rules for the ionic compounds stay the same. So we remember that oxygen does not end just as oxygen, but it ends in ID.